Hey everyone, in this video we'll be introducing agents with LangChain specifically. And as you can see here, this is a bit of a high-level agenda or outline of what we'll be talking about. First, we'll discuss what exactly is an agent, and you might have seen a bit of this in my prior video where I talk about basically the different ways we can kind of enhance or augment generative AI applications, and agents being one of the foremost techniques that's being used today. But we'll give a little overview in terms of what it is, why exactly we need agents, what are some realistic use cases in this world where agents can be used in Gen AI applications. Then we'll talk about LangChain. We've worked with this a little before, but I'll give a bit of a primer in terms of why it's useful, especially in this context. And then we'll have a very introductory hands-on demo with seeing how it could build an agent using the LangChain framework and our familiar service, Amazon Bedrock, just as the LLM of choice. But I'll link all the prerequisite videos down below if you're new to it, but we'll give a quick primer around all of those topics. And in the future, right after this, I want to dive more into kind of custom tools and agents, multi-agent systems, which is kind of like the talk of the town at the moment in the Gen AI space. And we'll get to all of those in coming videos, but let's kind of build some of the foundations here first in terms of what we're dealing with. So what is an agent, right? First and foremost is the question that we want to ask. And we know our LLMs, right? These are super powerful ML models that have been trained on gigantic corpuses data. They're huge in size, they're very, very intelligent, and can solve a lot of problems out of the box. But one of the constraints we talked about LLMs, just like any other ML model, is they're constrained to the data that they've been trained on. So in the case that an LLM ever needs external data to be able to solve a problem, we need to find a way to augment it with that additional information that it needs to solve that problem. So let's say, for example, you want your LLM to write SQL queries for your database in a default type of manner, just like a data analyst or someone else would. If that LLM doesn't have access to your database, then there's going to be problems, right? It's not going to know what exactly to write because it doesn't know your schema. It doesn't know exactly what it's dealing with. So the big challenge or reason for many of these different approaches is enabling external data access to solve your business problems. And that's really the crux of it. And one technique that we talked about, right, was RAG. And I'll also link that video down below. And with RAG, this is when we provide a corpus or a knowledge base and we say, hey, the answers are here, augment the prompt with this context when you retrieve the appropriate information depending on what the prompt is, and give me an output. Now, this is fine, right, when you have offline slash static data with the info you need. But if you have more dynamic use cases or workflows, right, where you might have to access a database on demand, there might be a certain operation you need to conduct, or there might be a certain API you need to retrieve data from, right? Let's maybe think of another example, such as you're looking for top restaurants in New York or something of that sort. You might need to dynamically access an API, retrieve that data, and put it in a natural language prompt or natural language format for your end user to understand. And that's where agents evolved, right? When you really need API access, dynamic data retrieval and operations. Horrible spelling is always there. But essentially, in any use cases that require more customization, right? Because RAG can be a little rigid. With RAG, you're constrained to basically the corpus that you provide, and it's going to retrieve from there. Let's say you might need access from multiple different APIs or multiple different data sources to answer your questions, and you might need dynamic operations done on that data, and you might need maybe even real-time data access, not something that's offline or static like RAG, where that corpus is already existing, right? Though you can update that. Anything that comes into that play, that's where the need for agents really evolved. We needed something a bit closer to a human. Where a human, right, when you're tasked with a problem, you know the appropriate action to take. So if I, as a human, for example, right, am asked, what is the weather in New York today? That's, for example, where I live. My intuitive reaction is, let me go to the weather app and check. Let's say someone was like, can you calculate 45 times 35, something like that. My intuitive reaction is to go to the calculator app and check. So there's two steps to it. There's the reasoning as humans that we have, plus the action. The reasoning is where we decide what tool is appropriate to use. And I'm using that word tool for a reason. I'll explain in a second. And the action is based off what we have available to us. Let's use the appropriate tool to get what we need. Now, to mimic this with LLMs, right? This is very similar to having APIs, for instance, and it doesn't need to be an API in every case, but essentially, this tool that I'm talking about, right? These are just Python functions or programmatic functions, depending on the language that you're using, that encapsulate your business logic. So let's say if I, once again, returning the case of the weather, if I'm like, hey, what is the weather in New York? Rather than just going to the weather app as a human, maybe you have a programmatic Python function that says, hey, have a function, and maybe we can define this with some pseudocode here. Have a function that takes a state and a time, and then it returns the weather. And provide this to our LLM as a tool. And this is, let's say, it has more business logic here in terms of the API with the weather that it's dealing with, right? So this function, when we give this to our LLM, what it's going to look for is, hey, these are the two parameters that must be found in the prompt. In the prompt, if I can't find these, I can't execute this tool, for example. But if I do find them, and if I deduce, right, that I need to get the weather in New York on this date or time, okay, there's this tool that I can use. The appropriate parameters are there. Here's the business logic for accessing that API. Return the weather in the format that, for example, that function's explaining. So at a high level, right, these Python functions are just our business logic, just like you would in a traditional application. It's just our business logic for interacting with these APIs. But what we're doing is we're letting the LLM pick from these different functions slash tools. So maybe you have something like get restaurants. And for this, you might say in the prompt, we need cuisine and maybe the number of guests. And then we can return the restaurants. And you'll have whatever business logic here for the API that you're working with. Let's say maybe something like Resi or something of that sort, right? With the LLM, we basically give it this toolbox, this set list of tools essentially, and we say, depending on the prompt, you reason and understand what is the exact tool I should be using. And once you do that, take a look at what exactly is the business logic for that tool. What are the parameters it requires within that prompt? Does my prompt contain that? And if it does, then execute this, right? And this can that's in the case of executing one tool, but this can get more advanced, right? Maybe you have multiple of these tools working in conjunction. So if you have something like, for example, the calculator app, and you're like let's say we have the weather tool that we're working with, and you say let's get the weather in New York at this day X, Y, and Z, and it says it's 75. And let's say in the prompt you're like get the weather in New York and multiply that output by 2, and then maybe you have another tool called calculator or something of that sort. In that case, it will execute first that get weather tool to get the weather, and then it will execute the calculator function because it'll deduce basically that, okay, now that I have the output from this weather API, I can use this calculator function to get a final output. So essentially an agent, right, if I had to describe it at a high level, is it's going to reason from the tools and the prompt that you have and deduce slash execute a course of action. So this reasoning, which is very human-like, right, is introduced into agents via this framework. And this framework is known as React. And that's what I keep kind of emphasizing or returning to. There's different agentic frameworks like Rewu and stuff that we'll visit in the future. But the core one, right, is React, which was introduced in 2022, and I'll link the paper down below. But the essence is that by giving the LLM access to these different tools, basically, in the form of these Python functions with these strictly kind of built parameters and stuff, will let the agent take the right course of action from what the prompt is by looking at what it has access to via these tools. So that's where the reasoning plus action workflows really come into play. And you can imagine how powerful this is, right? When you might have multiple agents, and this is something we'll visit eventually, but let's say you have a supervisor agent, right? And this is getting a little farther ahead, but let's say you have a supervisor agent that's managing a team or a swarm of agents, which each have different functionalities. So, for example, if you're booking, if you have a travel planner, right? Let's say you have a travel planner, maybe there's an agent that specializes in hotel bookings. Maybe there's an agent that specializes in like itinerary. Maybe there's an agent that looks at flight bookings. And each of these has different sub tools, right? That might contain the functionality to execute the APIs or business logic that you have across each of these different kind of components. So that's where multi-agent systems become really, really powerful and useful in this world because we need something, right? At the end of the day, the whole purpose of Gen AI is to kind of automate stuff, just like most ML. And multi-agent systems and agent systems come the closest to mimicking a human or a course of thinking within a human. And within multi-agent systems, you can kind of build these modular components and workflows where you can assign action across different personas or agents essentially. So that at a high level, right? We'll get into that in the future in terms of multi-agent workflows. There's different frameworks for that we'll explain. But the main takeaway I want you to have from here is an agent really is that reasoning and action brought to an LLM by giving it access to different tools which will be interacting with the APIs or external data access or any kind of type of data that you might be working with. And RAG, for example, can even be a tool within an agent. So if you know, for example, that the answer is within the corpus of data, depending on a certain prompt, you can configure that RAG workflow as a tool that your function can access basically, or as the function backing that tool essentially. So those that at a high level is an agent. And what will help us build out a agent, right, is frameworks such as LangChain. And we'll also explore other frameworks such as Llama Index, Amazon Bedrock Agents as a managed agent workflow within Bedrock itself. But with frameworks like LangChain, right, if we remember LangChain, it brings objects and constructs that simplify Gen AI applications. So specifically, right, within agents, there's going to be managed agent classes that implement these different kind of React-based um, theories or kind of backend logic there. And there's built-in tools, for example, which we'll explore, popular tools that you can use, such as maybe Wikipedia scraping, maybe searching the web through something like Serper, Calculator, for example. And what we'll do is we'll get started with a few of these in our hands-on demo today, just to show you how you can configure tools for LangChain. But you can also build custom tools via LangChain. So what LangChain does is, right, it provides the constructs and APIs to kind of bring all of this into a singular interface that you can easily work with to kind of bring to your generative AI applications. And via accessing all of this, right, it becomes much simpler for us as developers because we have these pre-built constructs to just focus on our business logic for how we should be working with these different APIs or methods, right? And specifically, right, I think that's mainly what I had in terms of the kind of theory itself today, but in terms of the hands-on, just revisiting that agenda there, if we go there, specifically today, what we'll do is we'll use LangChain and build out a sample React agent. And what we'll do is we'll simply use some of the built-in tools. So there's built-in tools that come without the need for us to define any Python functions or things of that sort, because the LangChain community has already built that out for us, and that's kind of the beauty of OSS, right? But in the case that you ever have your own custom APIs, data access, or tools that you want to work with, you can also bring that to LangChain. So that's what we'll visit in the coming follow-up video to this, how you can define your own custom Python code, interfacing with different APIs like Google Maps or Spotify or things of that sort to build some sample applications. So with that being said, let me hop out of the whiteboard here and let me go to the IDE here. I'm in Cursor. Once again, strongly recommend to work with Cursor. It really makes it simple to get started with all this, and you can also kind of understand your code as you're working with it. I honestly use it to kind of generate and simplify a lot of the code I was writing out because I'm pretty messy when I'm building these demos out. So all the documentation and stuff you're seeing is actually from Cursor itself. So if I come here, there's a few files that I've set up, and I'll link the Git repo down below here. And by the way, the README was also cursor generated if it looks a lot more professional than what I normally do. But if we see here, I have a main agent class. There's a few different constructs that I've built within this agentic class that I'll explain. First, we need our LLM. Any agent at the end of the day has a core LLM, right? And for that, I've been using Amazon Bedrock. I'll link that video down below. It seems like I'm going to have a ton down below for those of you that are new, but I'm going to import my Bedrock client, which is basically how I can work with Bedrock itself through local IDEs such as Cursor. And with this Bedrock client, I'm going to use Claude 3 Sonnet. And if you remember within LangChain community, right, there's support for many different LLMs. It's model provider agnostic. So if you have an OpenAI API key, you can use that. If you're on Vertex AI, you can use that. In my case, I'm just using Bedrock because I'm the most comfortable or familiar with it. So from LangChain's chat models, I import Bedrock chat. You need your access key IDs here. I have them stored in my environment file there. For once, I'm not displaying that, so I don't have to delete it again. I set up my Boto 3 client here, basically. This is what's going to be used to be able to invoke Bedrock Claude. And I'm essentially saying, here is the LangChain object for the LLM. So another neat part about LangChain, once again, is it comes with wrappers, right, for all these different providers with that LLM class. So I've set that up. That's my first file I'm working with. And then the second thing that any agent has, right, is these different tools that we need to enable. So I have this tools Python script here. And within this, if you see from LangChain.tools, we can import some of the custom tools that exist within LangChain. So for LangChain, you can either bring your own custom tool, which is when you bring your own Python function with your business logic to interact with whatever API you're dealing with, or you can use some of the built-in tools that exist within the community. So these have been implemented for us. So popular things such as querying Wikipedia, Python REPL is for like basic calculator kind of expressions. This one I completely forget. I don't think I use it here, but just for searching current events or things of that sort. So what I do here is I define a function. I basically say instantiate these three separate tools. In some cases, some of these custom tools, such as Serper, will require an API key, so ensure you have that. But here, these three were simple to set up. I just grabbed them from LangChain. I've set these up. I've instantiated them. And now what I'm going to do is I'm going to prepare a tools list. And this tools list is basically what I'm going to give to my LangChain agent, which has Claude Sonnet powering it via Bedrock. And I'll say this is your toolbox, basically. Pick from the set of tools depending on the input query that's coming in. And if you notice, I'm going to give descriptions and the function too. So here, this Wikipedia, it's just a function. Like I said, it's just a Python function in the backend. And we're going to say this is wikipedia.run. Here's the name of this tool. And we'll give a little description here. So we're giving some natural language for our LLM to understand. Keep in mind, if you give absolute garbage here, it might not be able to pick up on what exactly to do here. But I say here's the description for what exactly we're dealing with. In the case of something like a custom tool we'll explore later, you might also have parameters that you tightly configure here just so that it's very, very clear to the LLM in terms of what parameters or inputs to look for in the prompt. And that's where something like Pydantic, where you can tightly kind of define the parameters that you're working with, is very useful. So here I just define the functions, which are the built-in tools that I'm using. I build these up and I set up this list of tools that I'm working with. Great, this is what I have access to. Now we want to encapsulate all this into a singular agent, right? And that's where, once again, LangChain is so useful because it comes with this built-in agent class, which pretty much wraps all this together. Here, I grab my LLM, which is Bedrock Claude Sonnet, the LangChain LLM object. I grab my list of tools that I'm working with, and I simply pass all this together into my agent. I say here are the tools that you're going to make accessible for it. Here's the LLM, and here's the key part. There's also an agent type. Like I said, there's different types of agents. The most base one that you'll see is the one that's based off the kind of description that we were talking about, which is reasoning and then acting, react. So we use that as the default here. There's different ones, like I said, like Rewoo and other techniques that we'll talk about in the future as we get more advanced with these agentic systems. But I enable that agent there. I set verbose to true, basically, because I want to understand the chain of thought or kind of the course of action that my agent's doing as it's going through. And now what I'm going to do is I'm going to pass in just a simple query here. So I'm going to open up my terminal here. Just clear all that out. I don't know why I ran that again, but let's run that. And let's say calculate 4 plus 4, and let's see what our agent is thinking. So now if you see, since I've set verbose to true, you can see that it's entering a new agent executor chain. Remember, all of this is kind of wrapped up together. And the thought basically is to calculate 4 plus 4, I can use the Python REPL tool. So it's processed the prompt, it understands what's the appropriate tool to use, and then there's this action input that it basically takes. So it knew the appropriate tool to use. Now let's say that we want to use another sample query. Let's say, for example, like, what is the population of Japan or something of that sort. Let's set that up. Let's clear that. I think I accidentally took out the equals right there. Right there. Let's say, what is the population of Japan divided by the number of ions it has? A little more complicated. And let's run that right there. And we'll see there's multiple courses of action it has here, and it's going to understand and walk through this. So once again, it processes the prompt. Here it will understand to answer this, I need to find the current population of Japan, and it'll first search Wikipedia because it has it accessible as a tool. So you'll see this in the Wikipedia, and you'll see the action input that's being passed into the tool is population of Japan. And what's so beautiful about this is, right, this is all just derived from both that tool and the natural language we passed in terms of when to use the tool for what. And if we see here, it's retrieving stuff from there in terms of it from Wikipedia, from what it has access for. And now once it has that, remember there's two parts of this question divided by the number of islands it has. So it then takes another action where it's like, okay, I have to see the number of islands in Japan. Let me use the Wikipedia tool again for that. And once that's done, you can see it's able to calculate it. So the final thought and action that happens here is it has the numbers now from Wikipedia in terms of the population, and then it divides it by the number of islands and gives you a final output in pretty clean natural language understanding right here. So very, very simple to set up. I think this took me probably less than 20 minutes just to wrap all together, obviously with a little help from our good friend Cursor. But the main idea here, right, is it's so powerful what you can enable when you give an LLM external data access to really solve real world business problems. I know this was a few dummy kind of questions that we walked through, but now imagine this in a setting where you have access to your database, where you have access to different APIs that you might be working with, right? So some of the kind of projects that we'll look into in the future, for example, is building a custom tool for music recommendations where it can read from the Spotify API and have access, for example, to my Spotify playlist. Maybe it has access to the Google Places API, where it has access to different restaurants and things of that sort, and it can curate something like a date night or a hangout or something based off of that, right? So the possibilities are a little endless with agents when you give it these appropriate tools with that logic defined, be it these built-in tools or your own custom tools in the real world, obviously, when you're accessing different things. And that's why you'll see more and more agents are becoming kind of state of the art in this Gen AI space because it's the closest thing to simulating what we can as humans in terms of the actions we take. So different use cases, just flight booking, itinerary planning, travel booking, things of that sort, like a whole vacation planner, maybe with a multi-agent system. These are all sample projects that we'll explore and kind of get familiar with. So that's why I wanted to introduce you to this concept first, because it's such a core building block in the Gen AI space. And as always, please let me know if there's any feedback or any questions in the comments. And if you want to, you can reach out directly to me on LinkedIn, Twitter, wherever it is. But like I said, there's so much more that's coming in this space. And I'll continue to keep you posted here. We'll explore not just multi-agents, but also custom tools in the coming videos too, so that you can build powerful generative AI applications yourself as well. But yeah, I think that's what I had for today. Thank you as always for taking the time to watch. If you enjoyed the video, feel free to leave a like and subscribe, and I will be back very, very shortly. Thank you, everyone.